Speaking of. You don't even want comments?
No. I want to comment.
They'll be here.
Sure.
Jesse, the first one.
Yes.
Outside.
Well, yeah, but where else?
The
Well,
picnic
here.
table.
Yeah.
The picnic table right there. So like if you do the picnic table, you walk across the sidewalk. I probably walk on the sidewalk. I'm assuming. Where did that door lead to?
Literally just right outside
To a sidewalk?
to this part of the building.
We don't know for sure.
That's what we don't know. I'm like too worried about like
Oh, you'll be fine.
United.
Yeah.
Like
You'll get home one way.
true, yeah.
Hello, everyone. Come on in. Welcome.
Thank you. Was that yours?
Yeah.
You got that.
Oh, you forgot my coffee. If you asked me this question an hour ago, absolutely. Nope. Moonshine. So that's how you get out of check. That's how I get through the day.
Medicine. I want to try it.
Just like the old days.
All right, hello everyone. Welcome back to the REU Summer Students Talk Series. We have a slight schedule change. Today is just going to be Elizabeth, and tomorrow we'll have an extra talk at the end. So tomorrow at 2 p.m. we'll have an extra talk. But today it's all about Elizabeth. So Elizabeth is attending the West Virginia University Institute of Technology, and today she will be talking to you about an interactive dashboard of GBT antenna data. So take it away, Elizabeth.
So thank you, Brent, for introducing me. So I am a information major at WVU Tech. I am originally from Fayetteville, West Virginia. And a few things I like to do in my free time is crochet, hike, and read. So the overall goal of my project was creating an interactive dashboard of acquisition data from the GBT. This dashboard can be used as a tool for looking at path observation or observation based on certain criteria. So the first step of the project was getting the data. So the GBT antenna manager writes antenna position data at 10 Hertz throughout the span. It writes one file per span. And so Thomas took all of these files from the past 20 years and sampled them at 1 Hertz. So that means he took one antenna position at every 1 second for the past 20 years. So that came out to be around 300 million antenna positions. From there, we down sampled into 300K, 30K, 3K. For majority of my project, I work with a 300K subsample, and occasionally I work with a 3K subsample. So in a table of the subsample of 300K that I work with primarily, with the information I would give in the modified Julian gate, the right section, the declination, and the azimuth and elevation of the antenna data. From the baseline data, I was able to get the galactic right section, the galactic declination, and the day stamp from the modified Julian gate. So with all that data, we started to plot it. So as you can see, we were plotting around 300,000 points, and you can't really see each individual point because there's so many in one area that all that kind of blur into each other. And so you can't derive any information from the projection because there's too many data points on there. The one solution that we have is using a Python library called Data Shader. The Data Shader shades the data based on the number of points in an area. So area with higher number of points will be shaded like a bright gold yellow color, and an area that have lower point are shaded like a red or so. So that using Data Shader, we're able to see patterns in our data. And now we can glance at the projection and see where our most observations taking place at. And like we can just see it right here, and you're able to just see the dispersion.
Is this one with the galactic equator running along?
No, the J2000, the coordinate system.
Oh,
So the galactic plane is. So from all the projections, we created a dashboard. And so in the dashboard, on the left, you have the widget that you're able to filter through, and on the right, you have the projection. What we have three projections: the J2000 coordinate system, the galactic with the galactic plane, and then azimuth and elevation of the thing. The very first few things that you're able to do is change the background color of the projection. Right now, I have it that you can have gray, black, or white. You can also change the color map. There are a variety of color map widths. And so being able to change the background color and the color map just allow the user to view their data however they would like it. If there are certain color themes that they want to use with Data Shader to shade the data, you're able to change the color map. If you want to need the different contrast, you can change the background color. Another thing that you're able to do is change the spread threshold and the spread map pitbull. The threshold change is how, when you're spreading the point on the projection, how far you spread them apart from each other. And the spread map pitbull is the maximum number of pitbulls you spread on each side. Another thing that you're able to do is rotate the projection based on right and declination. With the widget, you're able to slide all the way to a negative 180, so you're able to rotate it to a negative 180 degrees. And then the height is you can rotate it to 180 degrees, and that just allows you to do a full rotation. Being able to rotate the RA and that just allow you to view the data in a non-normal way that you usually project it on a map, so at different angles at different areas. You can also constrain the date range of the observation or the data point. With the slider, you're able to slide the minimum date range to a certain point in the maximum. So if you only wanted to look at observation from 2007 to 2010, you can move the range to that time frame because they help you tune into the observation that you only want to look at. If you don't care about reading the data in like 2012 and so forth, just constrain it. And you're also able to change the projection by receiver and backend. If you hit your one receiver, it will populate a list of backends that go with that receiver. So that prevents people being able to hit a backend that doesn't go with that receiver you're looking at currently. You're able to look at one receiver and all the backends, or you're able to look at one receiver and one backend. And you're also able to group the backend so you can multi-select the backend with the one receiver to see a group of them. There are a lot of flexibility with that widget. You can also filter by session. So in the same premise of all the other widgets, if you hit one session, it will only populate the projection with that session. Also, you're able to multi-select, so you're able to look at multiple sessions of the projection. So another cool internet tool that we're able to use is the Quadmesh hover tool. So a Quadmesh is a 2D rectangular grid that is like laid on the projection, or you can think of it like that. So using the Quadmesh, there are Quadmesh over the projection with like with rectangle, and each rectangle is called a bin. And we were able to use those bins to see how many points are in that is contained in that bin. So when you hover over with the Quadmesh hover tool, you see that rectangle, and that rectangle is a bin in our Quadmesh grid. And now we're able to see how many points are in the rectangle. And so that just helps you see exactly how many points we're looking at. Sometimes it's just hard to see the point at a glance. Then at least tell you you're looking at 2,400 points per second. And you're also able to zoom into the projection, and then the Quadmesh will like resize. So now it will show the accurate amount of points that you're zooming in at. One thing I wanted to note is the right position and declination that you're seeing on the hover tool is the projected coordinate system number and not the actual location of the point in the bin. That is something that we're still trying to get working to show the accurate location. So data shader are very important because it enables us to look at large data set on a map more easily. However, there is some downside to that. So data shader return a black and white image to us. And so when that happens, we lose all the metadata of the point. And when we lose the metadata of the point, there's certain features that we're not able to do anymore. And so I don't want to demonstrate some feature that we're able to do with the raw point and what we can't do with the data shader point. So for performance-wise and visualization-wise, this is a projection of the 3,000 subsamples. So not the 3,000. So one tool that we're able to use is the lasso select tool, that we're able to select point on one projection and highlight it in the other projection. So this helps that if you're looking at one area on one projection, you're able to see it on the other one as well. It can help like locating it. Another thing we're able to do is link the projection to a table. So currently on the right, all of the information of all the points are in that table. If we use the box select tool, which just it kind of like the lasso tool, it just highlight certain points. So using the box select tool, you're able to highlight certain points, and those highlighted point information will be populated into that table. You can get more precise with this, and you can zoom in, and then you can highlight 7 points if you really want to, or 1 point. Right now, this feature only works with one projection at a time. Yeah.
I can't quite see what all is listed in that table. You just go through what columns.
Yeah, the video will jump through. So the column are the same column at the very first slide I showed you, the modified Julian date, the right set, the declination, at-net elevation, the galactic RA, galactic the date stamp, and then this one also showed you the receiver and back end of the observation.
Does it show you the project?
No. So the library I use for the whole project is HoloView, GeoView, OK, and Data Shader. So future work is getting more information in that table that you are able to use. So for example, maybe the project that the data came from. Also wanted to work on getting the Quadmesh to show the accurate location of the right ascension and declination. And overall, try to get it to work with 300 million antenna data eventually. So in conclusion, you can now visualize observation. You're able to interact with a dashboard to kind of scale down the observation based on certain criteria. And I hope that now you can see that it can be a fun tool to look at observation in the future.
Thank you, Elizabeth, for a really amazing talk. What we'll do now is we'll go ahead and take questions from the audience. So if you have any questions for Elizabeth, go ahead and raise your hand.
So I know a lot of people that are very interested in various bits of this. So are you planning to make this available to staff, to the world, et cetera?
In the summer, I'm gonna give it back to Thomas, and I know Thomas is working on a big GBT archive project. So maybe the project can be implemented on that project as well and be at that for other people.
So I have an answer to this question. I want to hear your answer to this question. What would you, no, it's not like that. What would you use this for? If you were?
I think, from my understanding, getting archive data is a little bit kind of messy. And so you can then hopefully, like, you can look at the point in the sky, and then it could link you to the archive data that have more information of that point. And so maybe it will be an easier way to access of, instead of looking through what the file, you're able to use the dashboard to look at the point, and then we'll lead you to the information.
Cool.
That what you're.
We have the same vision.
If we have any questions on Zoom, you can feel free to unmute yourself, but we have one more question in the audience here.
What other data are available to be basically put on these maps besides just the actual azimuth and elevation points?
So are you at like the data set I was given, or like?
Yeah, I guess besides just the actual coordinates of the points, what other data in the project bits files can you pull from it and put it to the points?
Visually, I think I can only make visualization of the antenna data of like the coordinate. I was able to pull out other information from the fit file, like the date, the modified join date and stuff, and the receiver in the back end from the file. I didn't visualize that other than in the table.
Somewhere I can see those some GBT file names from one of your slides.
It's probably the table.
Oh, like that. Oh, go forward one time. And, oh, right there.
Oh, yeah, the session.
Sessions.
So yeah, I was able to pull that from like the fit file, but I didn't like per se visualize it, and that was your question. I like, so we can create.
So if you point at something, will it highlight the?
Yeah, so if you hit, well, I didn't show that in the video demo because in the same concept, so you just like double tap on the session, V will regenerate and show only the point in that session.
Like get you towards the data, right?
Yeah.
Yeah.
Can you go back to one of the as-L projections early on?
I don't, oh, well,
You had one where you had like all the points or like 300 million points plotted or something like that at the very beginning.
the 300,000.
So why does it seem like the center, so you can see how things are rotating around the center point, right? And that's the north celestial pole. But why does it seem like it's off center? Why does it? You guys see what I mean there?
It's
This is a question for everyone.
It's elevation, it's not the north. The celestial pole should be off center. Elevation.
In elevation, but not, but
But
it
that
should,
is
but
elevation.
not in azimuth. It looks like it's.
This is
slightly
pointed
to the-
toward us.
No, it looks like it's slightly to the east or west or something like that.
I do not have an answer for that.
Well,
I
the,
don't have
you've got another one that shows it inside of this oval. Maybe it's not, maybe she just grabbed a piece of it.
The oval is just,
Yeah,
The north side, the.
it should be along the north-south hurricane.
Oh, right.
It looks like it's slightly to the right of the
Yeah.
line.
I think it might just be rotated.
Show us the one
That
where you
might-
got stuck
Oh.
inside of your thing. I think she just grabbed it.
It's a puzzle. I don't understand why. it would be rotated.
Keep going. Oh,
I
it
don't
might have been
have to
on
save
one
my
of the
color.
videos.
Hold on.
Yeah, this one.
Yeah.
That
Because
does
it's
make
in the
it
center.
look like it's, so what is the big circle there?
The circle is just,
I guess that's the entire.
a issue with the projection.
The outer ring would be directly below the GBT.
Yeah, so it's just showing stuff below the horizon.
Yeah.
I think it's in the center there.
That's not quite.
There's still some asymmetry there.
Yeah.
Yeah, the center is there and then bigger on the one side. That is,
What are these, what, oh, excuse. What are, so these are positions coming from the antenna fits files?
Yes.
But let's say you took a scan that was 2 hours long
Okay.
and the object is moving during the scan. How would that show up here?
I think it would show, so I understand, right, the antenna manager scans every 0.1 second.
Okay.
And so you're saying it will scan for 2 hours? Or-
So I think, maybe, so these are the actual antenna manager positions sampled every second.
Every second.
Okay, then my idea is not the correct. I thought maybe if it was just a position at the start of the scan, we like preferentially observe something as it's moving through, across the sky, and that might shift things, but that doesn't seem to be the case. It's a mystery, it's an interesting thing to think about.
Okay, we have time for about one more question. So Ellie in the back has a question?
Yeah, so I was just curious, does this include a break for listening as well?
I do not know that because it would just sample throughout area project.
Yeah, it should.
Yeah.
It's literally just everything in home archive. So it doesn't make any distinctions between projects or, I might have filtered out test data. I honestly don't remember. It doesn't make a huge difference one way or the other to the final look of the plot.
Thanks, great talk, thanks.
All right, nice job, Elizabeth. We do have a slight schedule change, so tomorrow will be tomorrow, on the end of the rest of the talk. So we hope we'll see you all again here at 2 p.m. tomorrow, so that we can hear from quite a few more summer students on the amazing work they've been doing. So nice job, guys.
But the whole region.
Thank you.
Oh, I got one.
Yeah, you can share with.
Alright.
Because I like having. But thank you so much for amazing.
fun, that's a job.
Thank you. I don't know.
They don't either.
Tell.
Oh my God.
Nice job.
Yeah.
Open the door right now.
All right.
Come back. Not right this minute. but you're gonna be on.
Right, yeah, I just wanted to introduce myself. Yeah, I like to chat.
It's 11.
Well, there is, you have time later this afternoon. I'm just gonna hear from one more team and then we're gonna.
You're welcome, and thank you.
Get our.
You might have
Ryan, so what we're on
This is-
next.
Oh my God!